Hello and welcome back to my workshop. My name is Robert. I've bought a diamond coated cut wheel for my tool and cutter grinder. In this video I'm going to mount it on the grinder and attempt to get it running true. This sort of wheel can't be dressed, unlike an aluminium oxide wheel, so getting it running straight is very important. Let's see how I get on. So this should be a nice easy job. I bought a diamond wheel off of one of the well-known Far Eastern sites, and I've got to mount it on here. I'm going to give it a try and see whether it works, see if it lasts, see if I wear it out, see whether it runs too fast. It's a 180 grit diamond electro-plated or electro-coated diamond wheel. Seems quite nice steel back, 20mm hole. This is 31.8, so won't fit on there, so I need to make an adapter. So whilst rummaging through my bin of rubbish, I came across this. Now at one time this was going to be an extension for the grinder here to bring the wheel much further forward, which is useful for some operations. Now it was pretty short-lived, this is a project though, because it turned out there was so much run out in the spindle that by the time you've amplified it to the end, this really did wobble. So I'm wondering whether this is going to work, because obviously you can't dress it. This material's rather convenient. It's got the 1/2-inch hole already bored in it and a keyway already in it. So the keyway only extends in about 1 inch, but that means I've got 1 inch material to make a couple of washers to go around this and fit it onto the spindle. First thing to do is to start off by taking off the wheel guard. The machine is turned off at the wall, and let's just free up the wheel and take this off. There we go, there's the keyed spindle. Right, first protocol, I'm going to put this in the forge hole, clock it true. This is very slightly undersized. Looks like it's about 1 thou or so undersized, so I'm going to stick a reamer through it. Now I've struck lucky here, that is just small enough to go through this forge hole. Good enough. I'm going to do this with some trepidation. I've never tried reaming into a bore with a key before. It is a spiral fluted reamer. Let's see whether or not this works. Can only go one of two ways. 180 RPM. Well, measurements say it should be good. So if I use this piece of bar here, that's 1 thou under. And that goes in there with a little bit of slop. It should be fine. So that bore should really fit. Well, I'm not brave enough to part this all the way off through the keyway because that'll end in tears. Probably end in tears anyway. But let's line up the edge of that there. Set the DRO. Let's go in 1/2 inch. I'll part it there. And just shy of the keyway, then get out the hacksaw. With a bit of faffing around, it's running within 0.01 millimeters, and on the face there are some saw marks there, but it's not too bad. I'm not working to any particular dimensions other than the 20mm. The outside diameter and the thickness are whatever they are. It doesn't really matter. Okay, I'm going to check to see how parallel this is. So, difficult to do one-handed, but even two-handed. That's coming out about 6.68. Let's try opposite. I've got 4 spots on there, so I know where I'm measuring. That's about 6.67. That's 6.66. And that's 6.67. So it looks like it's well within 0.02 millimeters. Let's find out what it's like when it's put on a spindle for run out. So if you wind that in, there's nothing pressing this back against the shoulder, but Let's rotate the 0 so you know where the starting point is. And if I rotate the other end of the shaft, we appear to be about 0.05 plus there and minus 0.04, maybe just a shade under 0.04 there. So not spectacular. Now that's why I say I think this shaft has a little bit of run out in it. If I measure the run out on the shaft, it's well within about 0.01 millimeters. But by the time I put something on, everything seems to go a bit pear-shaped. Now I'll have to move the camera to show you this, but I'll measure the run out on the concentric face that I've machined there. And try not to ill-treat the DTI at the same time. Let's bring you round. Now that's running out less than 0.02, just a shade under. It's about 0.008 to 0.008 in the other direction, if you can really judge the fractions of a line that well. So it's within about a thou on that face there, but this face here clearly runs out, and by more than the difference between the thicknesses of this bushing here. So what I'm going to do now is I'm going to take it off this motor. I'm going to put this on an arbor. It'll be one of the arbors that I use for the shaper for cutting gears. It happens to be a convenient 1/2 inch size, as this is a 1/2 inch shaft. And we'll measure out the run out on the face and on the shoulder then. At the moment, assuming that everything looks good on the arbor, my plan is to put this back on here, put a little bit of spacing on here, make sure this is orientated with the key, and then I'm going to take a turning tool, mount it on the table of the grinder, and I'm going to use this as a lathe, and I'm going to turn this surface in situ. Because of the key, it'll always go back the same way, so that should compensate for the run out. That's better than the run out on this here. So this face with the blue dots is going to have to be skimmed on the grinder. This other register here, I might just machine this on the lathe to size, make a tiny undercut at the back so that the wheel that fits on here can go all the way up, and then just using a sharp carbide tool whilst the grinder's running, just skim, what was it, 1/4 thou off of this face until it runs true, and then this will be the washer that sort of corrects everything, and hopefully that will keep everything running okay. What I'll do first, if I take this down to 20 millimeters, then mount everything up on the grinder, we'll put the wheel on there, see how bad it is, and then take a decision at that point. Just test it in several places, make sure that it is the right size. Feels good. So now try and get the camera to focus. There we go. About 20.03, so it's 20.02. It's a hair larger than 20 millimeters, about a thou over. That'll do. It's a tiny bit on the slack side. That is, it fits on a bit too sweetly without any interference, but there's no lock on it, so I'm going to go with that. Good. Okay, so let's try it. That washer on the back. And the wheel. Then a rather thick spacer. It could be a bit thinner. Wouldn't hurt if it were. And just nip that up tight and see what it looks like. I think that speaks for itself. And by the time it gets up to full speed, it looks pretty steady, but I don't trust it. Ready to get everything set up to measure it, see how bad it is, and then try and skim a little bit off. So I've got a stubby key here. Just enough to allow this to fit over up to the shoulder, but doesn't protrude any further. Half-inch spacers we made earlier, and the spindle lock nut. Just bring in a spanner and just tweak that tight. So that's now good to go. The key will make sure that nothing rotates when it shouldn't. Let's bring it around slightly so you can see the DTI. And let's see how bad it is. 0.1 of a millimetre. 0.1 of a millimetre, about 2 centimetres from the centre. So that wobble is going to magnify up by the diameter of the grinding wheel to about 0.5 millimetre, as it's no, 2.5 times that, maybe 1/4 of a millimetre. It's still too much. So let's get set up to machine that away. And here we are, the setup to machine this face here true. So this is my jig that you've seen before. It's got the attachment on the top that I made for sharpening lathe bits. Only this time the tool bit, it's a carbide tipped DCMT, I think it is. And so I've got in and out control on the hand wheel and side to side on the table traverse. So the spindle is aligned as close as I can to getting it perpendicular to the table travel. I'm going to move in we're about in the middle. I'm going to touch off and then just make a very, very gentle pass. That's touching there. Let's take 0.04 millimeters. Stop and see what we've done. There's still a patch just here which is not cleaned up. I'll tell you what, I blew it up. If I can find a pen. And let's give it another 0.4 millimeters, 0.04 millimeters. Thank you very much. Now we'll put the proper key in there. Make sure that's seated. Put back on the bush that we've just machined. The key will make sure it's in exactly the same relationship with the spindle that it had before. So now we can pop this wheel on, spacer on, which is a little bit generous. And nip that up. Let me just give the wheel a burst of energy and see how it's looking. Wobbly, I'd say. Terribly disappointing. So some little chopped up pieces of aluminium just to slide behind the top hat washer. Well, it's not perfect, but there's at least 2 thou run out relative to the front face. So I'm going to skim it. Let's set the feed to go in now. That's pretty good. Right, this is the wheel we've just skimmed. Let's find out. Let's bring you in closer. So if I give this a rotate, side on, it's not absolutely perfect, but it's a heck of a lot better than it was. Let's just spin it up slightly and see what it looks like. Well, I'm going to have to live with it. I've done just about everything I can to true it up. I've got the flat face of this bush trued in situ. I've got the rear of the wheel trued up to the face. I've left the bore alone. It's possible that if I bored that out a little bit bigger, maybe that would improve things, but is that really kicking it off? Who knows? It's not brilliant, but it'll do. I guess it's what you'd expect, given that these weren't exactly expensive, so there we go. So there we have it. Not a resounding success, but not a complete disaster either. It's on the machine and it runs. How well it works, I'll let you know. So, until the next video, thanks for watching.